And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we'll be talking about sunspots, more sunspots, the solar wind, some missing data, quasar perspective. And as usual, looking at images of the sun, we see another sunspot has formed up there in the northwest, right about where my pointer is. Major coronal hole system around the equator as well as around the North Pole area. Possible sunspot rising in the northeast. And sunspot 2776 continues on. We've got some great custom helioviewer movies for you. Here's the new sunspot. And I haven't looked at this one myself yet. It's formed pretty rapidly right as it's setting there. Put that on loop so you can get a good look at that. Might get named today. I believe it's sunspot 2778. Great perspective on that one. Here are some more custom views. Here's that active region rising and a massive filamentary region to its north. Great view of that. And at least on doing show prep, we did not see any sunspots associated with that active region. Here's the view in 171 angstroms. Some very interesting filamentary activity going on there. A little bit of a plasma tornado up here, sort of hanging out. Next, we've got a view of sunspot 2776 in 304 angstroms, as well as that setting active region down there. Great up-close view of that sunspot, complete with Earth scale. And here's the 171 angstroms view. It's all part of the SDO suite, helioviewer.org. What a great website. And whether or not that's an alpha or beta class sunspot we'll cover toward the end of the video. The radio flux is still at 75 solar flux units. And thanks to our new viewers on YouTube, our new subscribers, etc. For you new viewers out there, the 10.7 centimeter radio flux is a similar, it's what we call positively proportional to sunspot number. You can see how closely it follows it there on those two graphs of cycle 24. KP index is at 2. And we see some higher density solar wind kicking up, as well as some missing data. We saw some B-class flares yesterday, and there are those. Some flaring happened at 2300 and 1300. We don't see any major proton events, but we do see some high density solar wind. Not super high density. We've brought up the 1-year graph here of the solar wind data. And to our regular viewers out there, you've graduated to the 1-year graph of solar wind data. I just pulled that up because we were missing a bunch of data here on the 1-day chart. Let me bring up the 1-day chart, give that a minute to load. You can see a bunch of missing data from about 1 to 7 o'clock universal time. We did see an expansion here of the BTBZ. We're not sure exactly how high this got, but it's recently converged back to the zero line a little bit. We see some pretty big shifts in the sun's B field as well. We'll show you in a minute. Current solar wind density 17 protons per cubic centimeter. Solar wind speed 374 kilometers a second. And here's this high density nominal speed solar wind visualized in the magnetosphere. Keep in mind the dark blue shows high density, and we're talking about protons per cubic centimeter. That's high density regions. The white shows you low density regions. And we see a little bit of increased magnetohydrodynamic pressure here, apparent in the pressure data. I'll let that play through one more time. And then I'll check the chat and the live stream before we go on to ground magnetic perturbations. Yes, as we're living through a geomagnetic excursion. We've got two North Poles. One over northern Canada, one over Siberia, and the South Pole has migrated into the Indian Ocean, somewhere south of Australia. And just bear with me one moment, folks. Again, I would remind you that we did stream this live. If you've watched it in a recorded fashion, it's, we streamed it live. So here at the Smash News Network, we go to great lengths in order to get you the information. And we've got missing data here on the Space Weather Modeling Framework. It's not really showing us 4 hours of data here. It's only showing us like 1 hour of data. And indeed, the space-based simulations are the same deal. 1 hour of data. It's usually 4. And let's just check the Aurora forecast real quick, see if there are any significant auroras kicked off. Probably not. Well, let's look anyway. And again, give that a minute to load here. I apologize for the delay. I would expect to see a little bit of an increase in auroras toward the end here. And you do see a little bit of that mainly in the Aurora Australis as opposed to the Borealis. And we're not going to worry about induction. There's the GOES magnetometer. And we actually saw pretty low highs and pretty low lows there, having reached all the way down to 33.8 nanotesla. We also see some major magnetic changes happening in the sun. You can see some big swings of the solar polar fields there. North Pole shown in green, South Pole shown in red. One of the most important solar forecasting tools is this top view ecliptic plane field plot. It's all part of the National Sunspot Observatory. And here you can see some big yanks in the B field. No, I don't mean guys from America. Not that kind of yanks. Magnetic yanks. And next we'll look at the coronal magnetic field plot. And you can see some of those open potential field force lines from coronal holes there. Just approaching the Earth zone, look for the phi angle to swing into 180 degrees today, as we expect a magnetic connection to those coronal hole field force lines shown in purple soon. This shows regular open field force lines in black and closed potential field force lines in pink. Today's smash lights will be truncated. It will not be part of the daily space weather video, as I've got to do it separately today. We're going to briefly talk about a couple of things here. I would mention that big tech cannot break the internet, but the internet can break big tech. And that's sort of a teaser as to what we'll be talking about here at the Smash News Network. Have you found yourself shadow banned? Have you had your posts taken down? Have you been enraged about what's going on with censorship, disinformation, and propaganda? Well, we certainly have. But it's not going to affect our cosmology segment. Let's talk about quasars. Now, what's the deal with a quasar? The deal with a quasar is it's a matter of perspective. So it's what we call an active galactic nucleus. And it's not just an active galactic nucleus. For example, if you were located about here, this would be a Seyfert 1 galaxy. If you were located here, viewing this object at this angle, it would be a Seyfert 2 galaxy. And if you were located here, right in the poloidal jet, right in line with the poloidal jet, I should say, it would be a quasar. These are objects that are so intrinsically bright that it refutes a lot of cosmology. Today's featured object on the cosmology segment is Swift J0010.5 plus 1057. Here are the transients from it. And if you're wondering where that is, that's the Neil Gorell Swift Bat X-ray Observatory. And today we just went down the list. So this particular one, B0007, B0007 plus 107. There are the X-ray transients from it. It's, as you can see, a very consistent X-ray source. And let's zoom in on Simbad. And here is that quasar that we're talking about. You can see it does have a little bit of a spiral-looking sort of a structure to it. And that's just featured on the cosmology segment, just because we like our viewers to know about cosmology. Now, of course, it's a very interesting branch of science, and it's, well, in many ways in the process of being rewritten along with astrophysics, and in some ways physics itself, and certainly geophysics, as geophysics are all based on astronomy and first and second generation stars and the HR diagram and nuclear fusion dynamo stars that are made out of a ball of gaseous plasma, which just isn't a thing according to the observations. And that's why we do the cosmology segments. By the way, we are streaming live to Twitch, twitch.tv/smAsho. Again, thanks to our new subscribers over at YouTube. Please consider pressing like and subscribe if you enjoy the content. We're also on BitChute, bitchute.com/smAsho. And don't forget to check out our playlists on YouTube, youtube.com/smAsho/playlists. And let's get back to space data. Let's talk about electrons. There's a one-year graph of the relativistic electrons, and we are into geospace now. We're talking about some pretty important stuff here. The electron fluence around the planet. Where do all those electrons come from? Some interesting conversations coming up on Twitter. Make sure you follow us there as well. Twitter.com/smAsho. Making some connections with some interesting people who seem to know what they're talking about. NOAA's forecasting a small increase in the electron flux here, as we've seen it cratered for a few days. And until that proton density drops in the solar wind, we're not expecting to see that happen. We do see some anomalies in the total electron content forecast as well. Once again, you can see some major electron blobs here over North America. So some surprising levels of GPS errors there. And remember, folks, if you're using a GPS and you don't have the Wi-Fi accuracy enabled, you may see your GPS off by thousands of miles. I've done bike rides with allegedly, I think I did one with a 10,000 mile per hour average speed once. So that was pretty good. I mean, that's almost escape velocity. I have a feeling if I went over a jump, I would get some air at 10,000 miles per hour. Next, looking at just the ionosphere, it's just one slice of the atmosphere. The last one, that's the entire air column all the way to the thermosphere, since your GPS satellites are at a very, very high altitude. And there's the entire ionosphere, just the ionosphere layer rather, a full day of that. And it's looking more normal than it was of the past couple of days here. 2 and 3 days ago, it was much more anomalous. By the way, this data is from Australian Government Bureau of Meteorology. If you're up before dawn, you may see Venus and Mars. Venus, the third brightest object in the sky, which I accidentally forecasted would switch places with Mars, as now it looks more likely that there's actual life on Venus right now because of phosphenes in the atmosphere. And let me just check the life of the stream again here. We are looking just fine, just fine. And I'm talking in a stilted fashion. By the way, leave a comment. Let us know if you'd like us to do anything differently. And don't forget to check out our Smash Light segment, which should be premiering after this. Here's where stuff is in the solar system. I like to use theplanetstoday.com. This is the mobile view, by the way, just because it's a little simpler. You can do a geocentric view or to scale view or to show constellations and so on. There's where things will be in a week. Next, looking at earthquakes. We saw some extremely shallow quakes here. Check it out. I'll bet that one's under Mauna Loa. What do you think? It's at an altitude of negative 3.3 kilometers, right under the main caldera there of Mauna Loa. Check it out. That earthquake happening at negative 3,300 meters, so nearly around 10,000 feet of altitude. That 2.5 magnitude magmatic quake. There's another one at 900 meters above sea level. That's what you call a shallow quake, to say the least. Some deep quakes striking places like Tonga. This one is Northern Mariana Islands, a 5.2 magnitude. And just scrolling up the list here, a deep quake strikes China, as well as Afghanistan in the past 24. There's one of those deep quakes at Fiji. It's a 4.5 magnitude at over 540 kilometers depth. That's quite deep. And moving on to volcanoes, we see some new additions back on the list today, including Karimsky, now exploding, producing a 17,000-foot ash plume. Mount Ibu, also exploding down there in Indonesia, 7,000-foot ash plume. Likewise, similarly sized ash plume at Dacono. Popocatépetl, volcanic ash not seen in webcam or satellite. Please do not attempt to pole vault or tightrope the caldera. Fuego's exploding. Flight level 150, 15,000 feet. Sangay's exploding. 20,000-foot ash plume there. Continuous emissions at Sabancaya of volcanic ash. And an isolated puff at Villarrica is a reminder to not attempt to do a back handspring over the caldera. Here's the weather.gov map. We see this ongoing snow situation in places like Montana, Minnesota, Wisconsin, and the Dakotas, I imagine. Next, looking at the jet streams. There are the jets of the Western world, and some major bends here over the Atlantic Ocean. Here are the jet streams of the Eastern world. And let's do some more value-added services. How about pressure maps? We'll let it advance into the GFS forecast. I believe there's a hurricane possibly about to strike Bermuda, if I remember correctly. Let's just move this forward since it's advancing so slowly. And there's where we expect things to be at 12 o'clock my time tomorrow. Check out that powerful low pressure system there. That's actually a lower pressure system than this one. And that's a tropical system. But this one here, it looks like 28.84 pressure. And this one's 29.33. Another weaker low pressure system right over the middle of the U.S. We saw a line of lightning here striking from Lake Erie, from Cleveland all the way down towards St. Louis. Looking at the real-time maps here at lightningmaps.org. Hey, Terre Haute. There's thunder rolling in. Here's a NASA lightning mapper. And that's going back to about 6:30 Universal Time. Some major lightning there south of Florida as well. U.S. Doppler radar map is next. Heavy storms there over eastern Michigan, as well as northern Ohio, central Indiana, central Illinois, and central Missouri. And we'll zoom in on that in the water vapor map, as opposed to showing you the cloud layer. This will be a little bit more insightful into telling you what will happen with your weather. We've got quite a few viewers from these locations. It's pretty much going to stick to its path here and just go northeast without a lot of variations there. Now, there's a little bit of dry, massive air down here for this to bounce off of. And let's also look at Wyoming here as we see a little atmospheric pond forming on the leeward side of the Central Rockies there. It's an atmospheric pond. Thanks to our patrons, the real source of funding for the content. Please consider becoming a patron. It's patreon.com/smAshomash. Our patrons increase the probability that we will continue to make these videos and continue to make them free and publicly available. Don't worry, patrons. The likelihood of you not being able to see them is very, very low, as even if we decide to take the entire YouTube and BitChute channels down, and Twitch, you'll still see the content, most likely. It's just that nobody else will, because we're sick of not getting paid for our efforts. Please consider supporting the channel via links below the video and so on. Check out smAshomash.org. Thanks to the Smash team. Again, visit our links. smAshomash.org will redirect you to smAshomash.com. There are all of our social media links. Here's me socially distancing. I've socially distanced to the point where I've vanished. By the way, let me just reiterate. Big tech can't break the internet, but the internet can break big tech. One of the links you may want to visit is the smAsho store. Today's featured shirt is the one I'm actually wearing. Smasher priced my first pandemic. Let me show you. There you go. It features a mask on the whole world and a Fisher-Price-like child holding onto the mask, and it's an homage to mankind's pathetic and infantile response to COVID. What a joke. A bunch of people who don't know what they're talking about at all are now making policy decisions, as well as censoring the internet and so on. While mine's in black, you can also get it in colors. If you prefer to get it in color, we've also got it in pink, lime green, red, gold, orange. Going hunting? Would you like to tell your hunting buddies about smashomash.org? Well, do so with the shirt. By the way, thanks for flying American Smashways. Please keep your head and arms inside the Smash plane at all times. We've got bonus of features. Today we're going to look at the 94 angstroms 48-hour SDO video, which should show you some bright spots at some active regions and some sunspots. We're going to show you the intensitygram. And as we do most days, we're going to show you the colorized magnetogram. There is likely sunspot 2778. Here's 2776. The trailing umbra have continued to degrade, and the leading umbra has shrunk a little bit. There's that active region. Again, I don't think we're going to see any sunspots there, at least not at the moment. So there's that region. No umbrae there. And the trailing umbrae are, I believe they're gone. And the leading umbra has shrunk here at 2776. However, up here in the northwest, we see an umbra. Could be two umbrae, but I clearly see one. Looks like an alpha class sunspot to me. Here's the 94 angstroms view. Here's me making sure that I've vanished. Please leave a comment if our videos have vanished from YouTube, or if your subscription has vanished, or if your posts have vanished from Facebook, or if your comments have vanished, or if your phone has mysteriously broken down and prevented you from tweeting or putting up Facebook posts. Let us know about it. We can see those solar flares there coming out of 2776, kind of toward the end of the video. Some X-ray flares there coming out of it, some B-class flares. Right in here. Anyway, we are out. We're going to make another video for you, so don't forget to view that. It'll be a Smash Lights segment. Thanks again for tuning in. Remember, stare at the sun, don't drink, and if you do, don't drive. certainly don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back and those COVIDiots absent from your doorstep and from your governor's mansion.